Okay, morning everyone. Welcome to this session number 461. Finally, I come back. I was sick, but well, today we have this problem. Yesterday I tried to solve, and previously I tried to solve this problem, but until now I am close to solve. Do you see? I tried a few times, but until now I don't have the right answer. I am very close, and let me explain a little bit this problem. The problem is the continuous subarray sum, and well, given an integer array nums and integer k, return true if nums has a good subarray, or false other ways. We only need to return if we found one subarray, it's enough. We can return true. Now, a good subarray is a good subarray is a subarray where its length is at least 2. Okay, the minimum number or the minimum numbers that should contains this subarray is 2, and we don't have any maximum. And the sum of the elements of the subarray is a multiple of k. Yeah. Now, note that a subarray is a contiguous part of the array 1. It's obvious. And an integer x is a multiple of k if there exists an integer n such that x is equal n per k. And this is important. 0 is always a multiple of k. Okay. Now we have this this example. Now, for example, here. Okay. Now, the first point concern of this problem is that um, the way to discover if the any number is a multiple of the another, we can use the module, because, for example, if we have here, I don't know, 18, and we have that 6 is multiple of this because the module of this, it's equal 0. When the residual is 0, means that is a multiple. Another value is not a multiple of this number. Okay, this is the first point. Another point is that where we need at least 2 elements. Means that, for example, if we have one array of like this, yeah, and k it's equal 6, for example, 6 and 6 is a multiple, yeah, it is equal 0, but it's not right because it's only one item, yeah. In this case, we need to get the sum of the this. In this case, is appear the prefix sum, 6, 9, and 10. Okay. Now, for example, here, the prefix sum, sorry, the k it's equal 13. Yeah. And now, if we apply this, in this case, we need to calculate this value and continue with the next, because in this way, we can avoid that. For example, if the first element is this, we can avoid that return true because it's a module of this. It's a multiple of k. Yeah, in this case is 23, 25. Okay. And now we need to ask 25 module of 13. In this case is, I think that is 12. No. No, yeah, it's 12. Yeah. Now the next that is 31, and again 31 module of this is 6 is 26 is 5. Uh-huh. Is 5, and 35 module of 13, it's equal 26, 20 is 9, right? And now here is 42 module of 13 is, I think that is 4. Let me check. 4 is 42 module of, oh no, is 3. Okay, I am wrong here. Yeah, because it's 39, 40, 41, and 40. It's 3. Yeah. Now, in this case, any one of these is not multiple of this number, but the problem mentioned that it's a subarray, not all the array. In a few times happened that the total sum is the multiple of k, but in this case it's not. How can I discover, for example, in this case is 13, is 2 plus 6 is 8, 12, no, 7, 11, 17, 21. Let me check. 22. In this case, I think that is not possible. This is false because I don't. It's not possible find a multiple of 13. 23, 2, plus. No, no. I think that in this case it's not possible. Yeah. Now, what happened if k it's equal, for example, you know, 7? Okay. In this case, 2, oh no, 2 plus 8, 8, 12, 19. Okay, in this case is 25. No. 2, 8, 12. Here is 2, 8, 12. No. Okay, another number, for example, 4. This case is 2, this is 8. Okay, in this case, for example, the one subarray is multiple of 4 is this. Okay, even I can take this or only this because it's 2 plus 6 is 8 plus this is 12. 12 module of 4 it's equal 0, and the other is 2 plus 6 is 8 module of 4 it's equal 0, 2. Yeah, we have two subarrays that the multiple is k. But how can I discover this? Well, I learned that we can use the module for find this subarray, and the way is that basically apply the prefix sum and have all the time, for example, is calculus the prefix sum here, 23. The first always it's only calculate the prefix sum and the module. In this case, is the prefix sum is 0 plus 23, well, 23. 23 module of 13, it's equal, well, in this case is 12. Let me check. No, in this case is 4. Sorry. I will remove this. And is 23 module of 4 is 3. Okay, now we have the residual of 3. Got it. Now the next is this 25 module of 4, it's equal 1. We have 1. Now the next that is this 25 plus 6 is 31. 31 module of 4 sorry 1 2 is 3. I think that is 3 is 31 is 3. The residual is 3. Okay, got it. Now we have 3 here. Now in this case is interesting because the trick in this problem is that where you find a duplicate number, for example, in this case, the duplicate number is this, the 3 and the 3 appear 2 times. Where appear another time means that between these elements appear one multiple or appear the one multiple of, in this case, 4. Yeah, and 2 is multiple of 4. Yeah, well, it's opposite in this way. Yeah, in this case is 0 because 2 plus 2 is equal 4 and is similar to that 4. Okay, now the problem with this is that the length of this element is only 1, and the problem mentioned that need at least 2 elements. Okay, now in essential the way to discover if it's one element or the subarray is the size of the T subarray is 1 or 2 or any number is with the position. Yeah, and it's only we only need find the first coincidence of these rules. The first is that where the number is duplicate, in this case 3 and 3, and the difference should be greater, the length should be greater than 1. At 1 or greater equal to, yeah, whatever. Now the way to do this is simple. Basically it's only matters the first time that appear this number we need to save, and the next, if for example in this case appear the first time appeared 3. Yeah, this is the first time that appear in the index 0. Okay, now the next is 1. We don't have another. Now appear this. In this case, we know that previously I have 1 3, but the length is not enough. Okay, in this case, this can be ignored. Why is not replacing this? Because, for example, if another 3 appear here, now the calculus is between this and not between this. Yeah. For this reason, it's only enough save the first time that appear the value, and if appear again but don't don't have this validation of the length, well, it's only ignored. Yeah, in this case for do this, it's only necessary create a map, you know, in this case the key and the value, and this is the number and the index. Yeah, now for example in this case 23, the module of this is 3. Okay, in this case the 3 appear here. No. Okay, this is the index. The index is 0 1 2 3 and 4. Got it. Now the next that is 25, because it's the prefix 25 module of 4, it's equal 5. No, it's equal 1. It's equal 1. 1 appear here? No. Okay, I put the module. In this case is the module. Okay, I think that is here. Okay, now 1 in the index, 1 because don't appear before. Now the next that is 25 plus 6 is 31. 31 module of 4, it's equal 3. Now is asked 3 appear here? Yeah. Okay, what is the index? The index is 0. Okay, is the current index less less 2, 0, 1, 2, it's equal to, okay. Why? It's because it's this. Yeah, it's this, but no. Because it's 8, and 8 is a module of 4. In this case, okay, where you find the subarray is between the number, including the last coincidence, or the second coincidence. In this case, for example, is between this. This is ignored. This is only the limit. It's excluding. In this case, we have this. In this case, is 2. Means that the sum between these elements is a multiple of k. Okay, let me check with another example. For example, this. Okay. Oh. Now, in this case, we have our map here. Okay, this is the module. This is the index key value, and the prefixum is this is the index, and the prefixum is this 23 module of 6. It's 5. In this case here is 5. 5 is here now. Okay, 5 in index 0. Okay, got it. Now 23 plus 2 is 25. 25 module of 6 is equal 1. It's 1. 1 is here now. Okay, now is 27. Sorry, 27. No, 26 here. No, this is wrong. Is 25 module of 6 equal, it's 1. 25. Now 26. No, is I'm confusing the values. Now it's 25 plus 6 is 31. 31 module of 6 is 1. Yeah, in this case appear another 1. Here appear another 1, and in this case is okay, appear here in the index 1. Now the current is the current index is 2. 2 less the other index that is 1, it's equal 1. Don't have the enough length to that mentioned here in the constraints. Yeah, means that this is not enough. This is not enough for is not enough the length. Why is not enough? Because in this case, if you remember the previous example, is the current index current index until the previous plus 1. In this case, the previous is this plus 1 is this, means that this is a multiple of k, but the length is only 1. Yeah, in this case, it's not enough, means that I can ignore. This value is not override because, for example, if here appear another 1, again, the length is not enough. With this, it's possible. Yeah, for this reason, it's only important the first here. Okay, is ignored. Now the next that is 31 for plus for no for no plus 4 is 35 module of 4. It's equal is 5. 5 appear here. Yeah, the current index. Sorry here. The current index is 3 less 0 plus no. In this case, 3 less 0, it's equal 3. Okay, this is greater equal 2. Yeah. Now, if we apply the rule is current index, the multiple is between this and the first time plus 1. In this case, the first time is 0. 0 plus 1, it's equal 1. Okay, it's between 1 and the current index is 3. Okay, it's between this and this. 2 plus 6 is 8 plus 4 is 12. 12, this is a multiple of this. Yeah. Now, this works. Yeah. The problem that I have is what happened where appear like this. For example, 6. No. For example, 0, 0, 3, 0. No, let me move this here. In k, it's equal to 2. In this case, the 0 is considered as a multiple. Where? Okay. In this case, for example, if I follow this logic, is 0, 0 modulo of no. I think that is an error here. Is 0. But the other is the same. Let me check what is the error that yesterday. This. Okay. And k it's equal 5. K it's equal 5. And in this case, for example, the first is 0. 0. In this case, is 5. The module of this is 5. Okay. 5 in index 0. Got it. Now the next that is 1. 1 module of 5. I think that is it's 1. It's 1. It is 1. 1 appear here. No. Okay. In the index 1. Now another is here. 1 plus 0 is 1. And now is 1 modulo of 5. It's 1. In this case, appear another 1 here. Yeah. But the length is not enough because it's 2 less 1, it's equal 1. 1 is not greater equal 2. That is the minimum length. Okay? 0, 1, 2, 3, 4, 7, 8. Okay. Now it's not enough. It's ignored. Okay, now the next that is 1 plus 3, it's equal 4. 4 module of 5, it's equal 4. It's equal 4. Where is minimum minor that the k is the value. Okay, now is 4 modulo 5, it's 4. 4 appear here, no, okay, 4 in the index 2. Now the next that is 4, because it's 4 plus 0, it's 4. 4 module of 5, it's another 4. In this case, I found the here exists the 4, yeah, 2 less 2. Wrong. This is 3. The current index is 4. 4 less 3, it's equal 1, is not enough. Yeah. Now the next that is 4 plus 4, it's 8. 8 modulo of 5, it's equal 3. 3 is not here. I put the index. Now again, 8 module of 8. Is 8. Module of 5, it's equal 3, and is 6 less 5, it's equal 1, is not enough. Now the next that is 12. 12 module of 5, it's equal 2. 2 appear here, no. In the index 7. And now the next that is another 12. 12, well, it's the same, but 8 less 7, it's equal 1, is not enough. In this case, following this rule is false, but in this case, I was returning false. No, I returned true, but it's false. And I return true. I return true. Okay, let me do the code. In this case, now the implementation of this is hash map integer for save the residual, and integer for the index. Map, it's equal new hash map, and the next that is the prefix sum. No, prefix is enough with the prefix. Now, no, it's only that. Now I need to transversal the array. Meanwhile, it's minor that nums dot length I plus plus, and now here is integer res, that the residual. Even I think that I can create here and only override the value. Res, it's equal, first is the prefix plus equal the current num. In this case is the first. It's 5 and oh, okay. Okay, now in this case the first number is 0. 0 plus 0 is 0. Residual is between prefix module k. Yeah, and now we need to ask if map dot contains key res verify if previously here another equal residual res. In this case, previously appear another value. In this case, not. because doesn't exist. Okay, where it don't appear. There appear. I think that is this. Now, what is the first time that appear? It's only map.put, and I need to put the residual and the current index. Yeah, and in this case, where appear, I need to check. Okay, if appear, now I need to check if the length between this is greater equal to 2, because in this case, where I need at least 2 elements. In this case is map.get, because I need to get the value, and is the current value less this. In this case, the current value of the current index is I, less map.get res is greater equal to return true. Another case, don't return anything, return false. Now, for this, let me use this example. Works. Why yesterday I will get a different. Okay, let me check another examples here. This problem have a lot of tricky test. But let me check. For example, in this case, this and this. This case, I return false, and it's true because this is a multiple of. Return true and it's false. Why? 23 this 25 plus 4 is 25, 29, 35, 42. Okay, it's because on the final, I need to check. No. Okay, I have those here. Maybe I need to check on the final value. Well, this is 7. The first time is 23. 23. Okay, I will perform the prefixum first at 23, 25, 29, 35, 42. Okay, now here, and here. Okay, now the first time is 23. 23 exists. Yeah, sure, because I need to. No, I am saving the value. In this case, the first time that appeared this is not contained here. Is for this. Because I am overriding, I am doing exactly the point that I mentioned here. Yeah, where appear another similar value. Here, where appear another one, but the length is not enough. I need to ignore. But in this case, I am overriding. Okay, it's only enough for an else if it's not contained. Even here, where is the first time that appear. Okay, is this problem. 23. You know what? I will copy Okay. And what is happening here? This is the prefix zone. Now I have the map here. Now is 23 module of 7 is 2. In this case, the module is 2. The residual, sorry, is 2. 2 in the index 0. 0, 1, 0, 1, 2, 3, 4. Okay, now is 25 module of 7 is 4 because 7 plus 3 is 21 and the residual is 4. 4 and the index is 1. Don't appear is the first time that appear. Okay. The next is 29. I am returning false. 29. In this case, the residual of this is 1. 7, 14, 14, 21, 28, and the residual is 1. 1 appear here? No. Okay, the index is 2. Okay, now here is 35. 35 module of 7, it's equal 35. This case is 0. Okay, yeah. It's because where appear the 0 means that because in this case, for example, appear the 0 and the 0 means that is a module of this. Where is this, or the rest it's equal 0, but we need to be carefully here because, for example, if k is equal 7 and the first number is 7 or 14 or one multiple of k, in this case it should with this simple validation return true, and it's not true because I need to have at least 2 elements. In this case, I think that it's only enough that I should be greater than 0. Yeah, in this way I am sure that is at least the second element. Okay. Okay, finally. Yesterday I had an error with the zeros, but I'm not sure why. Let me check my previous code. Okay, the first time I was validate the length, but this is not necessary because I am handling here. Now prefix plus equal k. I was trying to solve this problem taking the 0 as a k. Yeah, but this is wrong, completely wrong. Yeah, I think that is essential for this. Oh, finally, okay. Let me publish the solution. I think that is not the best. Okay, I think that if I change this validation at the beginning, I can get a better approach, better performance, sorry. But this is a little more faster. Well, I think that, yeah, it's okay. Now, now solution. Oh, right. Appear another equal residual or no. Verify if the residual is 0, but it's not a first element, or if the previously sorry, I forget how write this word. Previously appear another that equal residual, but what is the first time it appear? Okay, I think that simple solution using prefix plus module. And name of the problem is okay. I will check the other solution because I learned this. Yeah. No, brute force caused this. Yeah. Previously, I tried with this, but no, it's not possible for the time limit exit. No, this is the brute force. This is the first. Cumulative with 2 pointers. Okay. Let me check Java. Well, but in this case, it's not is slow compared with this, I think, because I need to traverse at first all the array, and in this case is only enough with one or with a single loop. In this case, I need 1, 2, 3. No, it's more. Yeah, this is slow. Here, this is not necessary. I can do this because the first time the map is empty. Uh, uh-huh. It's equal 0. Okay, it's equal 0. Don't make sense this. It's only enough with this operation. I less is greater than this. Okay, in this case, handle this way for instead of this. No. Instead of this, use this operation or this ternary operation. But I think that is more complex. I think that this is more simple. It's a comment. Okay, this is very similar, but this is not necessarily handled in this point because if you are validate this, the first time is empty. Don't make sense. copy from ChatGPT. Yeah, I am agree. Um, okay, in this case, handle separate the conditional where the sum it's equal 0 and I it's greater. Yeah, this is exactly the same that my solution, but in this case, it separate the conditionals. But well, mm, okay. I like this problem. I save a favor. And I think that it's enough. Thanks for following this transmission, and I hope see you in the next. Bye bye.